Today's lecture is about the bandwidth utilization and how we will utilize the bandwidth. So for this, we will use the multiplexing scheme. This multiplexing scheme will be used that how we will utilize our bandwidth. The introduction to this is when the transmitter capacity of the medium linking two devices is greater than the transmission needs of two devices, then link can be shared. For example, when there is a transmitter and suppose there are two devices and these two devices share either so when the so this is the link between these two devices and this is the link between two devices. So if the capacity of this link is greater than the capacity of the device, then we will share the link to other devices. For example, the capacity of transmitter is smaller than the capacity of the load of the link. Then this link can be used for more devices. So for this case, we will use the multiplexing scheme. When the transmitter efficiency is greater than when the transmitting efficiency is uh, less than the link, so we will use the multiplexing scheme. So whenever the transmitter capacity of the medium linking two devices is greater than the transmission efficiency of transmitter, so the link can be shared. For example, the large water pipe can be carry water to several separate houses at once. So the multiplexing is the set of techniques that allow simultaneous transmission of multiple signal across single data link. So what is the multiplexing scheme? Multiplexing schemes are those schemes and techniques which allow the multiple data devices to send the data in single link. For example, these are three devices and they want to send data to these three devices. So we will use the multiplexing scheme. So what is the multiplexing scheme? There will be one transmission line. So there will be use mux multiplexer. So they will take the signal of three devices and send this in a single link. And there will be demultiplexing. They will divide the message signal to all these devices. So it means this link is shared with all three devices. We cannot say that this linking is only for device 1 and device 2, device 3 and device 4, device 5 and device 6. We say that this is the link between the 1, 2, 3, 4, 5, 6 devices. It means that we share this. So how we will share this link? So for this we will use the multiplexing schemes, and this process is called multiplexing. So the multiplexing scheme are the FDM and TDM. So they will be discussed here, but now we want to define the multiplexing. So multiplexing is the set of techniques that allow the simultaneous transmitters of multiple signals across a single data link. As the data communication usage increase, the traffic also increase. So we can add new line each time a new channel is needed. So in this case, we can install higher capacity link and use each to carry multiple signals. So as the data is increased every time, and the more devices are connected to the networks, so for this the link we will use the link whose capacity is very large. And when the capacity of the link is greater than the transmitter, so you can share easily to the more devices. So for this we will use multiplexing. All the and the medium which is used for such case are coaxial cable, optical fibers, and they have very high bandwidth. So each of these has carrying capacity far to excess of the need for one signal. If the transmitter capacity, so if the transmitter capacity of the link is greater than the transmitter needs of device attached to it, then the excess capacity is wasted. For example, the capacity of this link is greater than these three devices. So this is greater than 1, so we add 3 devices. Now it is also greater than these 3 devices. So it means that we will use some portion of this link, but the maximum capacity will be wasted. In this case, when the transmission efficiency of the link is greater than the all attached devices to the link. So in this case, some capacity will be wasted. So we can install other devices to use its capacity. So set up techniques that allow simultaneous transmission of multiple signals across the single data is called multiplexing. Multiplexing are those techniques which allows the simultaneous transmission of multiple signals across a single data link. When we use a single line or optical fiber or coaxial cable, and this single line is used for different devices for multiple signal, so it means that this is the techniques of multiplex. So how we will send multiple signals simultaneously in a single data link layer. For this we will use the multiplexing techniques. So in multiplex system, n devices share capacity into one link. For example, there are two examples. In this case, there is no multiplexing. No multiplexing, and here we have used a multiplexing scheme. So in this case, this device is connected to this computer. This PC will share this data link, this link with this PC. It means that the capacity of the link will be greater than the capacity of these transmitting devices. And here the efficiency of the capacity of the link is greater than the transmission capacity of these two transmitter, and same case is here and same case is here. So we can use single line by using multiplexing scheme. So we will add a single line, and there we will use mux. And what is the mean by mux? This is multiplexer, and you have studied this in your DLD course. So in this course, the multiplexer will the multiplexer is used to send the data of this device, either this device in a single line. In a single line, at the end there will be demultiplexer. This demultiplexer will convert into its required signals. So there will be two scheme, multiplexing and demultiplexing. So in the transmitter side, all the signal is combined by mux to a single line. In the case of receiver, demultiplexer will divide the received signal into different signals. When we combine four signal to a single signal, so this is called multiplexer. In here we divide a single signal to four different signal, so this is called demultiplexing. So in this case, there are four paths. In this case, this is a one path. So now let's suppose the figure show there are two possible way of linking four pairs of devices. In the figure A, each pair has its own link. If full capacity of each link is not utilized, in this case, the total capacity of the link is not utilized, maximum of the capacity will be wasted. In the case of B, the transmitter between the pairs are multiplexed and the same four pairs share the capacity to a single link. So the figure B shows that the basic format of multiplexed scheme. So this is the basic format of multiplexing scheme, that how we will combine four or more than four many devices to send the data into a single line. So the four devices on the left direct their transmitter stream to be mux, which combine them into a single stream, and the receiving stream is fed into demux, which separate the signal back into devices. So what is mean by far the physical link between them, and what is mean by channel? A portion of the path that carry the transmitter between a given pair of device. One path can have many channels. So what is mean by channel? In the previous example, and for previous example, this is a one path, but there are four channel. One channel is used for this device, and one channel is used for this, and other used for this. For example, this is the one channel, this is the second channel, this is the third, and this is the fourth. So this device and this device will use this channel, and they will use this channel, and they will use this channel, and they will be this channel. So there are four channel, but there is a one path. And here this there is a one path and one channel, one path and one channel, one path and one channel. So in this case, the maximum capacity is wasted, and this case the efficiency of this wire is entirely used. The multiplexing, so there are two types of multiplexing. One is frequency division multiplexing, and his name is FDM, and the other is time division multiplexing TDM. And when we will use time division multiplexing, and when we use the frequency division multiplexing. So if the link capacity is greater than transmitters and receiver, so we can use FDM. They will combine the signals of more devices into a single line. But if the capacity of the link is smaller than this, the three devices are more devices, by three mean more devices. So in this case, we will use time division multiplexer. At specific time, it will send the signal. At specific time, this will send the signal, and then this device will send the signal as the capacity of the wire is smaller than the total capacity of these devices. So we cannot share this. So this link will be used only by one device, but in specific time they will use by device 1, device 2, device 3, device 1, device 2, device 3. So for this case we will use TDM, and if the efficiency of this is greater than the entire capacity of this, so we can combine the signals of these devices into a single line. So we will use the frequency division multiplexing. And the time division multiplexing is subdivided into synchronous and asynchronous time division multiplexing. So what is FDM? An analog technique that can applied when the bandwidth of the link is greater than the combined bandwidth of the signals to be transmitted. When the link between the devices has greater capacity, have greater bandwidth, then the signal should be transmitted through this link. In this case, we will use frequency division multiplexing. So the signals generated by each sending device modulated at different frequencies. So you know that when you want to send a signal, so you will modulate them through a specific frequency. And we give the example of modulation is that when you want to go to Naushera from Temargara, so you are unable to go. But when you use the vehicle, so you can go to Naushera easily. So this vehicle is the modulator, is the modulated signal for you. You are the information signal, and this vehicle is the modulating signal. Is when we want to travel from Temargara to Navshera, so we sit into the vehicle, into a bus. So it means that we combine our carrier signal to the modulated signal. Then it will be go to Navshehra. In Navshehra, we will separate the passenger from the bus. So it means this is the demodulated scheme. So the signal generated by each transmitting device can be modulated with different frequencies. These modulated signals are then combined to a single composite signal. What is meant by composite signal? The combination of all signal is called composite signal. For example, this is the one device and he want to share this information. It is its information signal. This is a device and this is its information signal. This is a device and this is its information signal. So we can modulate the signal of device 1 to frequency number 1 and frequency number 2 and frequency number 3. So when we modulate this signal to f1 frequency, it will be look like this. And when we modulate this signal to this, so it will be see like this. And then we combine them by using adder. So this is the combined signal. Now this combined signal is the sum of these three signals. So this is called composite signal. The signal which is formed by the adding of some signal is called composite signal. And this is called modulating frequency. This is called modulating frequencies. So in this case, the carrier frequency are separated by enough bandwidth to accommodate the modulation signal. These bandwidth range are channels through which the various signals can be traveled. What is meant by bandwidth? The range of the channel in which the various signal can be traveled. For example, when device 1 want to send to device 2, they will use channel 1. So what is mean by channel 1? From this frequency to this frequency. So this is the range of specific, for example, for 10 kilohertz to 50 kilohertz. So the 40 kilohertz is the bandwidth of this channel. And similarly, the range between lower and upper. So this is called bandwidth. What is mean by bandwidth? Frequency 2 minus frequency 1. Frequency higher minus frequency lower. For example, when you use the terminal, it means that you suppose you send your signal from 30 kilohertz to 600 kilohertz. This means that this is the bandwidth that when you use a terminal, so you will use this band. And for zongs there will be another band, for jazz there will be another band, and so on and so on. When you want to change SIM from one network to another, so they just change its bandwidth portion. Now they will send the data in this portion, not in this. So you can change your SIM from one network to another. But when we use this case, so you see that the channel 1 and channel 2 are overlap with each other. There will be interference. So uh, to reduce interference, we use this technique that there will be channel 1, but the channel 2 will be start from some distance. So this distance, this band of frequency is not used in either in channel 1 and either channel 2. So this band is called guard band, and guard band is used to reduce the interference between the channel. So frequency division multiplexing, they use guard band. The channel must be separated by strip unused bandwidth, guard band, unused bandwidth, that this is not used for any channel to prevent the signal from overlapping. And what is the function of guard band? To prevent the signal from overlapping. So for example, this is the multiplexing scheme, and this is the frequency division multiplexing, that when you call uh, from this network to this, so you will use this frequency band, and for second you will use the channel 2 band and use the channel 3 band. But to avoid the interference between the 1 and 2 and the 2 and 3, so you will we will use some space between channel 1 and 2 and channel 2 and 3. This space means some frequency range, and this frequency range is called guard band. So in the figure, the transmitter path is divided into three parts. Each represent a channel to carry one transmitter. As analogy, imagine a point where three narrow streets merge to form three-lane highway. It is behave like that. Suppose this is the road. Here the traffic go in this side, and this side the traffics and go in this side. And there are three bands. So this is the slow band. When you are driving slowly, so you should use this line. If you are driving medium speed, so you can use this line. When you driving very fast, so you can use this line. So it means this is some portion, some range. So it means that there are three channels: channel 1, channel 2, and channel 3. When you are when you drive slowly, so you can use channel 1, and when you drive medium, so you can use channel 2, and same as channel 3. So same case is here, that like this, there are three channels. So when device 1 want to communicate to device 2, so they will use the channel 1, and for these they will use the channel 2, and for these they will use the channel 3. Either analogy of these networks to our cellular network. In cellular network, when you use the telenar, so we use this channel. J's, we use this, and zo, we will use this channel. So, and this is called FDM. But FDM, TDM mean, what is mean by FDM, TDM? And what is mean by FDM, frequency domain? If multiplexing frequency domain mean FDM and frequency domain, and what is mean by FDM and time domain? So there are two domains. One is called time domain, a real domain, and other is called frequency domain. So in the case, for example, now you are studying a subject whose name is signaling system, and some of your student has studied that. That sometime you want to shift our signal from time domain to frequency domain, and why we shift this, the mathematics in frequency domain is simple as compared to time domain, and we will use the convolution techniques in time domain, while we can use just multiplication techniques in frequency domain. So in this is the frequency division multiplexing, but in time domain. So in time domain mean that this is our signal and this is our time, continuous time carrier signal whose frequency 1, and this is the another signal whose frequency is 2, and this is the another signal carrier carrier signal f3, and when we modulate them, so we will multiply to this. In modulation, there is a signal m of t. What is mean by m of t? M of t is the signal which is data signal, and they will be multiplied to the carrier signal CFT. So from the multiplication of this, we will get another signal whose name is called modulated signal. This is called modulating signal. This is called carrying signal, and this is called modulated signal. So when we modulate this signal to this, they will generate this signal. And when we modulate the signal number 2 to frequency number 2, it will generate the medium signal. And when we modulate the signal number 3 to the carrier 3, it will generate this third signal. And we add, just when we add them, and time domain mean that add this portion with this portion and this portion, so it will give this. So now this is in time domain, but when we use in frequency domain, so what is mean by f1? So f1 mean a specific range. To specific range will be start from some portion, yes, and this is the f2 mean lower and upper, higher, lower and higher. For example, take it. This is the signal in now this is the previous example, but the signal in this diagram is in time domain. Now we have taken convert them into frequency domain by applying some techniques whose name is frequency modulation. You will study this in your other subjects, that how you will convert from time domain to frequency domain. So it means that so for example, this is a device 1, device 2, device 3, and it's this is a signal, and now it's converted to frequency domain. This is converted to frequency domain. This is converted to frequency domain. And for this, there will be frequency 1, frequency 2, and frequency 3. So when we multiply to this, to this, to this, so there will be this is the signal number 1, signal number 2, and signal number 3, and there is a space between them. This space is called guard band. This space is called guard band, and they will go to toward receiver, and they will be transmitted toward receiver. So in the case of demultiplexing, in the case of demultiplexing of time domain, they will get this signal and they will pass from the filter. When we pass from the filter, they will obtain the three different signals. Then they will they will use demultiplexing. So the same signal where we multiplied will be multiplied back to it, and we will generate the same signal as they have transmitted. So this is called demultiplexing. For example, when you see here, so this is the signal, this is the carrier. When we multiply to this, it was this signal. And then we combine to this. So in demultiplexing case, in receiver case, first this signal will be filters. So when we use three filter, so they will filter his own signal, this, and we will receive this signal back, and this receive back. Then we multiply back this f1, f2, f3 to this, so we will get a same transmitted signal. For example, this is the composite signal, combined signal, and when we give to this, by we will use three filters. So this filter will block these two and will allow only this signal, and this filter will filter its own signal, and this filter will filter its own signal. Now we will use the demultiplexing scheme, and we will generate and we will receive the same signal here. Same case is here when the receiving bandwidth is that. So we will use the filter that from lower frequency 1 to higher frequency 1. So it will be passed from this filter. There are band pass filter. There are three we have discussed in circuit, that there is a band pass filter. So when we pass them from band pass filter, so in band pass filter, they will pass its own filtering portion. So they when we pass from this, so these are will be not pass from this filter, they will pass only one. And when we give this signal to this filter, they will pass only the signal number 2, and this will pass only the signal number 3. And then we use the demodulators, and we will get its own signal. So this is the FDM and frequency domain, and this was the FDM and time domain. So there are simple mean that in the case of FDM, we use the one line, one link between the transmitter and receiver by more devices. So these more devices can send the signal only in one line. So for this, they will use the multiplexing scheme. So one of the scheme is FDM. In this case, the transmitting capacity of the link will be higher than these three devices. Or if there are more devices, so the transmitter efficiency of the link will be higher than the devices who want to send the data. Now, suppose the TDM. So TDM is the digital process that can be applied when the data rate capacity of the transmitter medium is greater than the data rate required by the sending and receiving devices. This is smaller. So when the transmitting efficiency of this is smaller than the sending and receiving device, we will use the time division multiplexing. In such case, multiple transmission can occupy a single line by subdividing them into interleaving portion. For example, check it. Now, there are four devices: one, two, three, four. So this is the channel between them. In this case, we have divided this into a specific in a and we have divided this into time slots. For example, this is the time slot 1. It means that when there is a time slot 1, so the 2, 3, and 4 will not send the data. Only 1 will send the data. And when there is a second time slot, so the 2 will send data, and 3 and 4. For example, suppose there are 2 millisecond time, so it means that and from 0 to zero point 0.5 millisecond, the one will transmit the data. When there is a 0.6 to 1 millisecond time, the two will transmit the data. From 1 to 1.5, the 3 will send data, and similarly to this. So it means that this channel is not used at a time for all 4 devices. At specific time, a specific device will send the data. It means that this link is used only by one transmitter at single slot. In single slot, only one device can send the data. So this is called time division multiplexing. And when the transmitting capacity of the link is smaller than this, so in this case we will use the TDM, time division multiplexing scheme. So in the time division multiplexing scheme, there are two methods. One is synchronous and one is asynchronous. So there are the implementation of TDM. So TDM can be implemented by two ways: synchronous TDM and asynchronous TDM. In the case of synchronous TDM, the term synchronous has differed from the use of the other area telecommunication. Here, the synchronous means that the mux allocate exactly the same time slot to each device at all devices, whether or not sending the data. Simple, we mean that in this case, in synchronous case, for example, there are 4 devices: 1, 2, 3, 4, 5. So they will generate a frame. This is called frame. And this frame consists of time slots. For example, and from this time to this time slot, there will be the data of first transmitter, and this is the data of second transmitter, third transmitter, fourth transmitter, and 5 transmitter. So this is the frame number 1, this is the frame number 2 dot dot, and frame number and this is the frame n. So in each frame there will be slot. In this slot, this is the 1, in the second slot the 2, and the third slot the 3, and the fourth slot the 4 device will send his data. So for example, this device is not sending any data. It means that this slots will be empty in each frame. It means that there will be the waste of the channel. So there will be the waste of the channel. It means in the asynchronous case, there will be slot for each device. If there are 10, so there will be 10 slots. If there are 20 devices, so there will be 20 slots in frame. But if for example there are 20 devices, in 20 devices only 3 want to send data and other are not want to send data, so only 3 slots will be filled and all the other slots will be empty, but they will be move in this channel. It means that 17 slots are wasted. 17 slots are wasted. So this is very this is not useful system. Simple, we mean that the time slot are grouped into frames. A frame consists of one complete cycle of time slot, including one or more slot dedicated to each sending device. if the system with n, so input lines, each frame has at least n slots. In each frame there will be n slot, and in n for every device there will be a slot. If he send data, so they will use here slot. If they not send data, so its slot will be empty. So however, it is possible to accommodate varying of data rate. A transmitter with two slots per frame will arrive twice as quickly as one slot per frame. So this is the synchronous TDM. In synchronous TDM, the waste of the capacity will be occur. The time slot A per assigned to device. For example, there is another example. Let's check it. So suppose in time domain, how they will use the slot. So for this case, there will be a clock. For example, this is the frame 1. Now see that there are 4 devices and they send the data. They send A, they send B, they send C, they send D. So in first frame, when it is toward this portion, in when this arrow is connected, when the switch is connected to A, so A will send the data in his slot. Then it will be moved toward B in this direction. So when they move toward B, so the B will send his data. And when they enter to this, so the C will send the data. And they, when they are connected to this portion, so the frame is full of 4 type of data A, B, C, D. Similarly, in this frame, similarly in this frame. So after 3, this is the frame 1, 2, 3. So in case of 4 frame, when they are connected to A, so they will become A. But when it move toward this direction B, so they have no data to send, so its slot will be empty. When they came here to C, so C has data and D has data. But in fifth frame, the A has data and the D has data, and the data of the C and the B are finished. So there will be only A and D, and these 2 slots will be empty. In next case, only A has data and all other have no data, so only A will be seen. It means that these slots are wasted, but it is easily to detect. It is easily to detect because when the receiver receive this frame, so in the first slot the data will be sent to the A and to B and C. For example, check it. When this frame came here in receiver side, so when this portion, so they will give data here, then they move toward this, so the second data will be moved here, then shift this, so the next data will be came here, and so on. So this is the demultiplexing scheme. This is the multiplexing scheme. In the case of asynchronous TDM, this is the synchronous TDM. In the case of asynchronous TDM, so asynchronous TDM does not guarantee full utilization of time slot because the time slot are fixed and pre-assigned. Whenever connected to device is not transmitting, the corresponding slot is empty. So of the channel capacity is wasted. In the case of synchronous, for example, imagine that you have multiplexed the output of 20 identical computer into a single line. Using TDM, the speed of the line must be at least 20 times the speed of the input line. But what if 10 computers are in use at a time? So the half of the capacity will be wasted. By simple, we mean that if there are 20 computer and they send the data, but in 20 computer only 10 send the data, so the half capacity will be wasted. So asynchronous, so how we will reduce this portion, that we does not waste our channel capacity. In this case, the asynchronous TDM or statistical TDM is designed to avoid this type of waste. Asynchronous mean flexible or not fixed. So the synchronous was fixed. In a fixed slot, every will send the device will send the data, but if they have no data, so this slot will become empty. But in the case of asynchronous, they will send the data. If they have no data, so no, so the slot will be not fixed for that. It can be filled by other device. In asynchronous system, if we have n input lines, the frame contain no more than m slots, which m is less than n. So for example, if there are n devices, so the each frame will have m slots, but m must be less than n. For example, what is mean by this sentence? So in this case, there are 1, 2, 3, 4, 5, but the frame contain 1, 2, 3. So this is the m and this is the n. So in the case of asynchronous, we will first of all design that in the frame how many slot will be there. So for example, in this case, number of input is 5 and the number of slot in each frame is 3. So it will be depend on us. So in this case, when the if this device has data, so they will send they will receive, and then they will be received, and then they will be received. In the next frame they will be received from this and this, then back to the device number one. But if the device number one has no data, they will move toward B, and this slot will be filled from the data of the B. For example, check it. There are 5 input, 1, 2, 3, 4, 5. So, and in each frames, there are 3 slots. So this is the frame number 1. So in the frame number 1, so the computer 1 is want to send data A. Now, the time of, this is the time of 2, he has no data. So this place will be filled by third. So the 3 has data C, and the 4 have no data, so E5. So we have used the first one in this. And second frame, we will use A1, C3, and A5. Same, A1, C3, E3, E5, A1, C3, and E5. E5. Now, when this portion is done, it means that so in the last frame, they will check the data, take the data from 1, so A1. So they will move to this, they have no data, they have no data, they have no data, they have no data, they will back toward A. So it has data, so A1. Now they will move here. So no data, no data, no data, no data. Then back to this, they have no data. Now so this portion will be empty. So simple, we mean that we send the entire data into how many frames? 5 frames. And only one slot become empty because there will be no data, and all the slots can be filled. So it means that the wasting of the channel has been reduced. But in previous case, there was no need of the address 135. There, this is the data of the one computer, three computer, mean no need of address in previous example, but there must be added as sometime the A will be send data in first slot, and then maybe it can data into second slot, and so on. So this is the another example. For example, now these are four devices have data. In the previous example, out of five, only three have data. In this case, out of five, the four have data. So in this case, there are frame of three. So it means that in the first frame, A1, C3, D4. So the frame has been failed. The frame has been failed. So in next frame, it will be start from here, E5, then back to this, A1 and C3. So this is the second frame. Then they will the next frame will be start from D4, E5 and A1. The next frame will be start from C3, D4 and E5. Then A1, C3, D4. Then the another will start from E5, A1. So other have no data, so back to this A1. So when we see that in the first slot, the A1 data is the data of the one computer in first slot. In second, they will be moved to one second, and then they move toward third, and then there was no, and then back to one, and back to two. So it means that they have changed the slot position. So for how to detect that whose data, that this data for which computer, so we will add the address. So we will need the address mustly in this asynchronous TDM. In the case of synchronous TDM, no need of address, but in the case of asynchronous, we must apply the we must add the address of a specific computer. So this is these are the two techniques that we can use in the for multiplexing. Now, what is meant by inverse multiplexing? So inverse multiplexing means opposite of multiplexing. Takes data from one high-speed line and message inverse multiplexing means that it will take data from one high-speed lines and break into portion that can be sent over several lower speed lines. For example, an organization wants to send data, voice, and values, each of which requires different data rate. To send voice, it needs 64 kbps, and for data 128 kbps, and for video 1.544 mbps, and it can lease a 1.454 MHz line from common carrier and only use it fully for some time, or it can lease several separate channel of lower data rates. So it means that when we take data from the high speed, and how you will convert this into different slots, that the speed is sometimes this, and sometime this and sometime this. So for this technique you will use inverse multiplexing. When you want to take data from the high data speed and then divide into sub low speed, so in this case you will use inverse multiplexing. In the case of multiplexing, when you want to use single line for different devices, and the inverse multiplexing mean that when you use a different line for one type of data, and then you will divide into sub lengths. For example, this is the multiplexing. They combine n into single and demultiplexing one into differ. But what is the inverse multiplexing? Inverse multiplexing means that they combine one into differs. 1, 2, 3 n slots. And what is mean by the inverse demultiplexing? So they combine the 1, 2, 3 and so n into single line, single type data. So this is called inverse multiplexing. So there are how we can transmit data. So there are two types of transmission: parallel transmission and serial transmission, and serial synchronous and asynchronous. What is mean by parallel? So binary data consists of one and zeros, may be organized into group of n bits, and each by grouping we can send n bits at a time instead of one bit. For example, this is a sender, so they send the group of data 1, 2, 3, 4, 5, 6, 7, 8, 1 byte data, either 2 byte, 3 byte simultaneously. So this means that this is parallel sending. But when they send one by one like this, they have data 0, 1, this. So first send the 0, they first send the 0, then 1, then 0, then 0, then 0, then 1, then 1, then 0. So when you send data bit by bit, so this is called serial. And when you want to send the entire data or group of data at a timely, so this is called parallel transmission. And we use sometimes this and we use sometimes this is our requirement in practical life. For example, now you are studying the controller and microprocessor. So in this case, for example, there is its output portion, and there are some devices there. We want to operate the device by our command. So we will send parallel data here, and sometime in controller we use to send the data zero bit by bit to control our system. So this is called a serial, and this is called one the previous is called parallel, and this is called serial sending of data. So it will depend on the time that which type of data we will want to send or receive. So this is the all about today class, that what is mean by multiplexing, and what is the and why we use the multiplexing. And there are two techniques of multiplexing: FDM and PDM, and there are two types of TDM: asynchronous and synchronous, and what is mean by inverse multiplexing, and how we will send data parallelly either serially. So this is all about today lecture.